So in order for the client to connect to the network for the first time, they are going to have to perform a handshake, which is a fancy way of saying the client and the access point have to exchange a bunch of messages to agree upon some state. So we'll show this handshake in two different ways. First, we'll show it to you in a conceptual way, and then later we'll optimize it to make it a little bit faster, although the optimized version looks a little bit more confusing. So first, here's the less confusing, intuitive version of the WPA handshake. We have two people we're dealing with. One is the client. This is like your computer trying to connect. The other person is the access point. They are sitting on the network waiting for others to join, and the access point will help users join the network. So the first thing the client will do is send a request saying, I want to join the Wi-Fi network. Now, at this point, both the client and the access point are going to derive a key from the Wi-Fi password, and they will do this independently and offline. You might stop and wonder, why doesn't the client just send the password to the access point? Because then an attacker might view that packet and learn what the password is. So instead of directly sending the password, which is not so good, we will instead have the client and the access point independently, offline, derive this key from the password. Now, this handshake has a lot of keys, so I've color-coded them for your benefit. This key is the one in blue, and it has this acronym. Now, at this point, the next step is to exchange random nonces. These are kind of like the nonces from the cryptography unit. It's just some random value to make sure that each handshake looks different. So the access point sends a random value, the client sends a random value, and that's it for step 3. Now, at this point, we want to introduce randomness into our scheme. So here's what we're going to do. We will take the key in blue that came from the Wi-Fi password earlier. We'll take the nonces, which are in red, and we'll also take the MAC addresses of the client and the access point, and we'll throw all of them into some sort of cryptographic function, like a hash, and we will output another set of keys called PTK, which I've color-coded in purple. Now, one thing I'm kind of proud of is that if you take blue and red and you combine them, you get purple. It's all part of the plan. So what we've done is we've taken the key in blue, we've taken the random values in red, we've mashed them together using some deterministic algorithm like a hash, and we get these purple transport keys out. Now, at this point, we need to make sure that nobody has tampered with anything so far. For example, an attacker might have tampered with the nonces, and that would be bad. And they could have also tampered with, I guess, the authentication request, although that would be kind of weird. But they could definitely tamper with the nonces, and we don't want that. So one thing we're going to do now is exchange MAC codes to make sure that nobody has tampered with the nonces. Now, this is another place where terminology is just annoying. So here, where we're deriving that key in purple, we're using the hardware MAC addresses of these two computers. And here, where they're exchanging message authentication codes to make sure that nothing was tampered with, we're using message authentication codes from cryptography. So unfortunately, the same name appears twice. We just have to deal with it. It sucks. Sorry. And finally, one more thing we'll do is we'll have the access point send another key in green, which we'll call the group key. And this is useful if the client wants to broadcast messages to everybody. So something we'll see after this handshake is over is that these purple keys can be used by the client and the access point to exchange data between each other. But if the client wants to talk to everybody on the local network, they have to use this green group key so that everybody else can see it. Green and group also kind of sound similar. Also part of the plan. So that's the WPA handshake in intuitive form.